In this example, we've been asked to find the domain, x-intercepts, y-intercepts, and all asymptotes, and then ultimately graph the function. I will use our 8-step approach to graph this function. Our first step is to find the domain. To find the domain, I need to first look at my original function and look specifically in the denominator. My domain is all values except what would make the denominator 0. So in this case, it would be all values except what makes x equals 2 equals 0. If I solve that, I'll get x equals -2. So the domain would be -infinity to -2 union -2 to infinity. The second thing I want to do is find my x-intercepts. To find my x-intercepts, I first need to factor the original function. We can see that the top may factor. The bottom is already factored. Looking at the top, I'm looking for factors of 8 that add or subtract to -6. So I may be able to use 2 and 4. If I make both of them negative, the -2 times the -4 would give me +8, but -2 plus -4 would give me the -6 in the middle. The reason that I need to factor before I find my x-intercepts is sometimes I have factors that cancel. The factors that cancel do not need to be included in my x-intercepts. To find my x-intercepts, I set the numerator of my function equal to 0 after I factor and cancel. In this case, nothing cancels, and so I would want to set x minus 2 equal to 0, and I would want to set x minus 4 equal to 0. Doing that, I would end up with x is 2 and x is 4. Now, when you're finding x-intercepts, you want to make sure to write them as ordered pairs. And so here, the first ordered pair would be 2, 0, and then the second ordered pair, 4, 0. Going on, I'd like to now find the y-intercept. The y-intercept is found by evaluating your function at 0. So I would do f of 0 equals 0 squared minus 6 times 0 plus 8 over 0 plus 2. Well, doing that, all the 0 pieces would cancel out. That would leave me with 8 over 2, and then 8 over 2 is 4. Once again, if it's a y-intercept, you need to make sure to write your answer as an ordered pair. Well, the y value is 4, the x value that I plugged in was 0, so the ordered pair would be 0, 4. As my fourth step, I'm going to make a note of if there are any holes in the graph. Holes occur where factors cancel in the original function. In this example, I factored the function, and then we see that none of those factors cancel, and so I'm just going to make a note that there are no holes in the graph. The instructions on this one didn't specifically say to look for holes, but that's something that we need to keep in the back of our mind, because when we graph a function, if we have a hole in our graph, we need to make sure to indicate it on the graph. From here, let's look at asymptotes. So for asymptotes, we would first look at vertical asymptotes. Vertical asymptotes are found where the denominator of the function is equal to 0. This is only after we have factored and canceled anything that would cancel. Well, this example, nothing cancels, so my vertical asymptote would be found by setting the denominator to 0. So x plus 2 equals 0 would yield x is -2. A vertical asymptote needs to be written in the form x equals whatever value. So x equals -2 would be the proper thing to do here. The next thing would be horizontal asymptotes. Well, horizontal asymptotes depends on the powers of my original function. So if I look back up, we notice that the degree of the numerator is equal to 2. And then we notice here that the degree of the denominator is equal to 1. Since the degree of the numerator is larger than the degree of the denominator, we have no horizontal asymptotes. So just indicate that by saying none. Finally, we're looking for oblique asymptotes. Anytime there are no horizontal asymptotes, there will be an oblique asymptote. We find this by long dividing the function, basically by taking the numerator and dividing by the denominator. So we'll set up a long division type problem, x plus 2 on the outside, and then our numerator, x squared minus 6x plus 8 on the inside. To long divide, look at the x and x squared. We know we need an x on the top to be able to get x squared. Distribute that down. So x squared plus 2x. Draw a line, change your signs. First two cancel as they should. The next I get is negative 8x. Bring down your 8 and then start over. So to start my long division on this next term, look at the x and the negative 8x. Here I'd need a negative 8. Now when I get to this last constant, I know that whatever's left here is going to be just a remainder. So I can actually stop, because if we remember correctly, with oblique asymptotes, it doesn't make a difference what the remainder is. And so when I get this very last constant term here, I can actually stop. So in this particular case, I would end up with y equals x minus 8 as my oblique asymptote. Now, this has a y-intercept of negative 8, and then it has a slope of 1 over 1. All right, from here, I now want to collect this information and I want to graph. So as step 8, I now want to graph my function. On here, if you want to get graph paper, that might not be such a bad idea on these particular functions. On certain parts, it makes a difference how accurate you are. First thing you want to do is you want to go back up to the top and you want to collect any kind of actual ordered pairs that you have. So we have our x-intercepts here and we have also our y-intercept. So I'm going to go down and I'm going to plot those 3 points to start. I'm going to make this, for the moment, I'm going to make it a 10 by 10. If I need to change that, I can later. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to do this in all directions. All right, and then to graph my ordered pairs, my x-intercepts were 2, 0, and then also 4, 0. My y-intercept was 0, 4. And so there are those points. And then from here, once I've graphed my points, I would graph any kind of asymptotes that I have. I had a vertical asymptote at negative 2. So at x is negative 2, I will draw a vertical line. Go ahead and label that for me so that I know specifically where that is. And then I also had my slant asymptote, and my slant asymptote was here. It is going to be a linear function. It has a y-intercept of negative 8 and then a slope of 1 over 1. So I'm going to try to be as accurate about that as I possibly can be. So I'm going to go down 8. Plot a point. And then remember here, this should be a dotted line, but I'm going to go up 1 over 1 to get to another point, up 1 over 1 to get to another point, and so forth. And then just draw a dotted line through those points. It should cross my graph actually at 8 up here if you're accurate enough. You don't have to worry too much about that, just making sure that you're actually crossing to the right of those ordered pairs that we have drawn. And then make sure also here, and I think I actually need to extend one of them, make sure that your asymptotes extend out enough, I'm going to say, to create, in this case, 4 regions. So in other words, we have the little triangular piece here, 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 and here. Okay, make sure that those 4 regions are clearly defined when you draw your asymptotes. Now, from here, I'm actually going to tell you what to expect with your graph. We see that we only have x-intercepts and y-intercepts up here in this region. And so I know that my graph has got to pass through those points, and then I know also that my graph has to be drawn towards the asymptotes. So here, I know I would get very, very close. I'd have to come down, actually go through that particular point, come down here. Do you see we'd be forced to actually cross through these intercepts and then turn around, and then as I come back up, I have to be drawn towards this asymptote out here. Okay, so it's going to form kind of a C-shaped. My drawing is not very good, so that does not need to be crooked, but it's going to form kind of a C-shaped graph going up this direction. And just be pulled towards that asymptote. Now, I know that I cannot be in any of the other regions other than this region. Over here, you see that there would have to be an x or y intercept because I'd be pulled towards these asymptotes, so I can't be there. Same thing there, I can't be in that particular region. So since those are out, this region at the bottom is the region that I'd have to be in. Because of that, I know what my graph looks like because I have to be pulled towards the asymptotes. I'm pulled in the middle of here, and I also have the C shape down below. Now you can check this using your graphing calculator if you would like, but just given the information that we have collected, we know that this would have to be the shape of our function.